Hello, Warsaw. First, let's give a quick round of applause for the Front Trends organizers for putting on such an awesome conference. And thank you for having me here. And I kind of have to, I'm just going to go to this. I have to apologize, I did eat all the pierogi. So hi, I'm Chris Wright, and I come from a faraway place called Sydney, Australia. And I work for an email company called Campaign Monitor, as that was just spoken about. And if you ever wondered what the web would have looked like without standards, all you need to do is view source on an HTML email. This snippet of code right there, that gives me anxiety. There's a calc in there. I'm not sure if you can see it on the screen. There's a calc in there of 28,000 minus 16,700, no, 167,400 pixels. It's amazing. This is a diagram showing just how to support a single email client. There are like over 20 email clients that someone could support. And so HTML email is a series of hacks built on other hacks. It's a house of cards. But what I wanted to talk to you today about was layout on the web, but more importantly, how we can be the change in getting the features that we want. So we'll look at how we solve problems by using features in interesting ways, sort of departing from functional fixedness, which is kind of the concept of using objects in a way in which they're traditionally meant to be used. And we'll explore how features of today can help us build the features that we don't quite have yet. And we'll do that by looking at the potential of features and ask what is unique to specific features. And we'll start that by looking back 15 years. Because if you think about it, the layout that we've used in the last 15 years was mostly built upon a technique that was designed for pulling images to the side of text. And that's CSS floats. And its predecessor tables was very difficult to maintain. It was very complex, and having the content right next to the layout often meant that we were prone to breaking the layout when editing the content. And having to search for that broken TD tag was often a nightmare. But it wasn't really until we got the ClearFix hack that really enabled us to be able to build with floats. And this particular ClearFix up here was actually my first ClearFix hack. It looks very different now, obviously. Going forward several years, and the feature that enables us to serve layout to different devices, the media query, was really originated around our need to cater to different media types, like projectors and printers. Because if you look back at when the proposal for the media query was written, it was actually written in 2001, long before the smartphone existed. In fact, I had a phone that was something like this, and the browser was text. And if you were lucky, you had a game of Snake on your phone. But it wasn't until we got the fluid image hack that we started to adapt to different devices. It was one of the key ingredients of Ethan Marcotte's definition of responsive design. And it used the fact that one defined dimension preserved the aspect ratio if it was defined. Then Retina came and ruined our bandwidth. So we blew up our images twice the size and saved out to zero quality to get a file size half the size. And I guess the thing I'm coming to here is that we make the craziest hacks. These are all great examples of how we solve problems by coming up with the craziest solutions for features we don't yet have. And those hacks create impact. All of the hacks I've shown you here so far have either become features or influenced them. If you look at these three ones, they've all actually become something else. The compressive images became sizes and picture. Fluid image hack influenced object fit, and the ClearFix hack is now built into a feature called display flow route. Hacks are our desire paths. And if you're not familiar with what a desire path is, they just represent the paths that people actually want to take. And some town planners use these to work out where to put new paths. As creators of the web, we make our own paths to show what we actually need. And there is a distinction. Some hacks are brilliant, and some hacks are really, really dirty. I think a brilliant hack is one that uses the unique properties of features to get a result. And I think Thierry Koblenz's technique for intrinsic ratio is an example of this kind of brilliant hack. It uses the fact that padding is calculated off the width of the block to produce intrinsic ratios for fluid media. And I think Hayden Pickering's quantity queries is also another one that I would sort of put into this category, which uses nth selectors and the general sibling. But there are dirty hacks, which tend to be about browser isolation. They tend to be about trying to fix one very specific browser for one very specific behavior. And they don't tend to last so well. They don't tend to have longevity. And then, of course, there are hacks that just never leave, like the fact that I think we'll forever have to manage the white space of inline block in different ways. But why do we hack away at features? Well, we do because our needs often grow beyond what the tools are capable of. Spec writers can't always predict the direction we're heading in or see the future, so they have to look at what we do. And for layout has probably been the most hacked area of the web. All you need to do is look at how many different features have had grids built around them. Display table, inline block, floats, flexbox, they've all been shoehorned into grids. And if you take one of these grids apart, there are so many lines of code to manage simple things like how columns should behave, or what should happen when the content needs to take up more than one column, or what should the gutter look like. And if you want to touch that over a media query, there's another 35 lines of code. Fortunately, we now have declarative grids. All of those hacked grids that people made became a feature. You're probably seeing a pattern now in my talk. With just a few lines of code, we can create the same effect. First, display grid. Second, we just add a gutter. And then we declare 2 columns. The number of values here relate to the number of columns, and the size of these values relate to the size of the columns. And if you're not familiar with the FR unit, it's called a fraction unit. It works by looking at the total number of fraction units declared, and then dividing the overall number by that. In our case, we have 2 fraction units, so each one is worth half. And you might say, why not just use viewport units? Well, because these will take care of the gutters that you put in the grid as well, and the viewport units won't. We can also represent that with a repeat keyword, and so we want to say that same thing with 1FR, 1FR, and we just say repeat 2. And there's also another handy property here called min-max, and that just takes a minimum value and a maximum value. We can do interesting things with our grid now, like we can create white space with ease. You can get something like this by telling the column to start later, start in the second column instead. And that just takes 1 line of code. And we can replace those 60-odd lines of code that I showed you in that previous grid framework by simply defining how content behaves across columns. All of those styles we saw can be replaced with span. And that actually opens up a new feature for us because grid works in multiple directions. So now we can go across rows as well, where before we would have had to tinker with markup in a way that's not so different from tables. We can also allow a grid item to appear to break out of the grid. And that would actually cause it to actually still be part of the grid. So marking up in the same way you would then say you want a heading that goes over the top of the grid. You would make it also a grid child. And to get the grid item to do that, you would then make it occupy the same tracks and give it a Z index higher than those items. And you get something like this. We can also use the span property to help us build up more complex grids. So the advice I always give people is start with a small block, because you can then start applying additively to each of these small blocks. There's no negative span, so that doesn't really help you if you need to go in reverse. Start with the smallest block that you have. And you can even make those complex grids, you can make those flexible and responsive. I'm hoping that, yep, okay. I was just checking that you could see the autofit keyword there. If you can't, because of contrast, there's an autofit keyword there after the repeat. For those columns, we're using a keyword called autofit. Autofit will try to fit as many columns on a row as it can. And so it's responsive by default, essentially. Now, you might have noticed that it had a whole bunch of rows there, and you can actually use something called auto rows, which I actually don't use the normal grid template rows. I just use auto rows all the time because it's amazing. Combined with span, we can then start to make a, let's get back. Combined with span, we can then make a complex grid that is also flexible. And grid will try to manage that as best it can. It does not want to show that. So with CSS variables, you can define values and implement them anywhere in the style sheet. And that can make things even more simpler for making your layout. So one thing you can do is define how columns and spans collapse across viewports by defining what a column or span will do when it is at its baseline, and then what it does when it's got behind a media query. And we just implement that in one single line of code, and the bit that needs to change its calculation, that's isolated in one place. So one of the key unique properties, I think, about CSS variables is that it allows us to create a relationship between values. And so when you're doing things like laying out the grid, it allows you to make things be relative to other things. So if you wanted to put padding on your page, you can tie that together with your grid gap. Well, one of the features that I kind of wish that grid had natively is the ability to create offsets. Now, if we go back to those grid frameworks that I was talking about, almost all of them have some sort of offset property, and it's a little bit disappointing that grid doesn't have that yet. What you would want is something to say that you want to add a little bit of randomness to it. And unfortunately, at the moment, the only thing you can really do is adjust negative margins and margins. And that always feels like heading towards the dirtier side of hacking to me. So you would define something like this. And in this case, I'm using the relationship. I'm using the size of the gutter to calculate how much I want to offset. And then just applying classes in that way. I mentioned quantity queries before. So this was sort of an experiment of what would happen if you were to use quantity queries with the span keyword. And you can do sort of interesting things here. So depending on how many items that you have, you could change the span amount in that way. And so you might go to have your standard classes for span, and then use the quantity query, which, as you see, uses the nth selector and the general sibling selector to help us change what the value of the span is. Everything I've talked about so far is more about page layout and how things are laid out on a page. But if you think about it, our needs have kind of shifted with the rise of the pattern library and things like atomic design. We've gone from coming from a place of building for static sites, static sizes, like 640 by 480, to a web that could exist at just about any size. And in recent years, the pattern library has meant that we've begun shedding the pattern, or the concept of the page. The building blocks of our sites and our applications are now more in the component. And they need to be able to be capable of existing at any place and at any size. And the first signs of starting to move to that, I believe, were when people were talking about adopting content-based breakpoints in responsive design. But this came at a cost. It meant that for every time we needed to modify a component or a design, we'd need to make a whole new set of breakpoints. And in larger scale sites and applications, this could end up being a maintenance nightmare. I actually looked at over 50 popular responsive websites, and this number is not made up. I found an average of 264 media queries on these 50 sites, which does speak to a bit of a tooling problem or a build problem, but I think it also is indicative of just how out of date the media query has become for our needs. And that is because the media queries are restricted to viewports and media types. If you look at how you might apply a media query to a component, you might say that by default, my component is single column, and maybe it'll be 2 columns at 40 rems. But the problem with doing something like that is it's 2 column by default at the top, but then I put it in a space over here to the right, and it's still 2 columns. The viewport has nothing to do with how that component should behave. So the dream for me is define once, use anywhere, and be able to implement in many different places without having to micromanage markup or CSS. And having available space as any constraint. These components really just have, what they have in common is that they're on this page, really. And so most of these things are just different versions of the same thing. Our need for media queries has evolved. And you may have heard the term container query or element query. But what's important here is it's the concept that you could define an element and how it would behave based on the space that it has available. So a news site, like The Guardian, might have something like a default component, and then it would have how the component behaves at, say, 30 ems. And this is not real CSS. This is a purely theoretical thing here for how you might define such a query. But the reason why we haven't seen this type of query yet is there have been a number of problems that have presented themselves. And the first of those is infinite loops. See, if you could style a component based on the size of its parent or on the size of itself, there's a situation in which you could cause it to keep going back and forth between its styling. The second problem is how CSS is parsed, because it builds the CSS OM and the DOM together and creates the render tree. It doesn't get a second pass at that. So there are a bunch of features on the web with layout that do container query-like things. They adapt to the available space that you can do, and those are unique properties of these specific types of layout. And I find these fascinating. The first of these is Flexbox, and a technique demonstrated by Zoe Gillenwater, who spoke here, can show us how we can create breaks in content without a media query. First, we add flex wrap to the container, and then we add fixed width to the child elements. So that 800 pixels that we see here becomes the point at which this component needs to break and become a single column. Of course, then it looks a bit like this, and you want it to continue stretching, so we put flex grow on it. And in practice, with a media object or some sort of profile, you can easily make it switch between 1 and 2 columns. And there are many other examples of this. Now, a more recent variant of that hack is the Flex Grow 999 version of this by Joran van Hee. And what he does here is he uses the fact that the Flex Grow is similar to the fraction unit before. It will distribute shares of space. One share goes to the one on the left, and 9999 goes to the one on the right. So if you've got 1,000 pixels, not many pixels are going to go to the one on the left, and it won't grow. And this will behave the same as the other one when it goes back to a single column. Now, I find multi-columns interesting because they're kind of like the neglected part of the web. It's like this feature we've had since, I'm not even sure, 2009 or something. And it just feels like people don't go near it because it doesn't behave the way they want it to do. It doesn't behave predictably. But columns have a unique property in that if you define the width of columns, but you don't define the number of columns, columns will automatically generate as the element gets wider. So you can have 2 columns and 3 columns. And you combine this with other features like Flexbox. So you might use the Flexbox technique from earlier, and then if we wanted to, deal with the fact that this component gets larger and larger, and deal with the line length of the type. And in practice, going back to the previous example with the media query, you can now kind of move this component around anywhere on the page, and it will deal with it. It will deal with line length in an interesting way. Grid, autofit, and autofill have kind of been, I feel, have been a little bit informed by this, and so we see very similar behavior to the Flexbox wrap technique. And I've already mentioned how this is done with autofit and min-max. Now, images are another important part of how a component might move around. And one problem is with the picture element is it only cares about the viewport. So what happens with bandwidth when you've got this massive image and you put this component on and it's a tiny image? Well, fortunately, SVG can have its own document context, which means if you were to put a media query inside an external SVG, it will treat the SVG as having its own viewport, which, coupled with the fact that you can also embed HTML in SVG, you could embed the picture element inside of the SVG, using the SVG as the viewport. So now picture has a container query. And you can see this as an example here. While, yes, I am resizing the page, you'll notice that they go independently of each other. The next case that I see with this sort of thing is type. And Vitaly mentioned fluid type before. And there are a number of libraries that have tried to deal with this, as well as Brent Jackson's excellent tool called Fit a Happier Text, which allows you to fit a heading to a page and to the container. If we look at Mike's technique, which, by the way, this slide, me and Vitaly, we both put the exact slide in our talk, makes a calculation of range. That's all you really need to get from this particular slide. It's a calculation of range. And so you can then resize, and the font size will always stay within that range based on the viewport. Now, I kind of wish that there was a container-size font unit. And I believe that this would help with headings. So Resize Observer has also been mentioned in this conference. And it is very experimental and only in one browser behind a flag. But it's important to try and play around with these things to give feedback and work out what we can do. Now, slight aside to this, we can use CSS variables to communicate. They're kind of the perfect tool, I believe, to communicate certain styles between JavaScript and CSS. We can get any particular variable with this line of code. And we can set any variable with this line of code. So what if we wanted to have container-based fluid typography? Well, maybe we could replace that viewport unit somehow. So this is the same calculation with one very specific difference. And so, as you can see, same range thing as before, except now we can do something slightly different. I'm very slow in DevTools. Now we can change the column, and all of a sudden, you have headings that are sizing themselves based on the size of the container. So how does that work? Well, I had to write some JavaScript for the Resize Observer. I've just got a function called reportSize, and what it does is it grabs the content rectangle of the element, which is the container, and then it sets some variables on the container to say, my element width is this wide, and my height is this high. Then we just simply select all of those. The only thing you need to know from this piece of code is we're selecting the things that we want to observe, and we're observing them. And in the browser, this kind of looks like this. It will inject those styles for element width. And we have a component that, by default, shows 100 viewport width, which is back to the calculation. And then it has something which will base a calculation on the element width. So then you got this horrible-looking piece of code here, which is just doing the same calculation you saw that was Mike Reithmiller's. And you get magic. Now, I tried a lot of experimentation with Resize Observer, and I encourage you to do the same. The problem with reporting element size directly to CSS is that CSS is very specific. If I put a class on something that is its element size, at size 733. Can you imagine how many classes I would have to write to manage how this works across different sizes? The problem is that CSS can't match a range of numbers as a selector. And the closest thing that we can get is using the attributes wildcard selector. And there is a problem with doing it this way. Because what if I had 7,000 or my match was 1 and then it had 1,000 something? So it's kind of problematic. But what we can do is when we are reporting the size, we could maybe calculate the ratio of the area and work out what the shape is. So we could say we're a tall rectangle, a square, a narrow rectangle, and we could then communicate that and define that on the component, how the component should behave if it's a tall rectangle or a wide rectangle or has a shape, certain shape. And one of those article previews might exist at different shapes like this. So Resize Observer is still very much an experimental technology and in a single browser. But I encourage you to try new things that browsers implement, because without our feedback, it actually takes us longer to get the features we want, and often we end up with weird, buggy implementations, and we go, oh, this feature sucks. Why did they do this? Because no one looked at it, no one tried it. So it's really important that we try things and we write about them. And this talk isn't just about what's exciting for today and tomorrow and what crazy hacks we can do. It's about our ability to shape our own path for the features that we want, and whether that's through hacking or experimenting. These crazy hacks we do bring visibility to the features that we want. Sometimes they gain traction, and sometimes they fail. But ultimately, it's we who create our own paths, and we can be the game changers. Thank you.